Here are our next examples of parallel and perpendicular slopes. And if you notice, these ones are not fractional. So these ones are kind of the more difficult ones. First, we have a -4 slope using up, right. And -4 slope means you're going to be going up -4. That means down 4. And right, 1. -4 over 1 makes -4. So we're going to go down 4, 1, 2, 3, 4, and right 1. Down 4, 1, 2, 3, 4, and right 1 to make a parallel line to our initial -4 slope. Both of these lines have a -4 slope. Now what gets interesting is if you have a -4 over 1 slope, how are we going to convert that into its perpendicular slope? Well, we know we need to flip the 1 and 4. And we have this negative. There's two ways of doing this. One is, well, this was a -4, so we really need to flip it. And then we need to make the whole thing negative. So we flipped it, and now we've added this negative sign here. A -1 over a -4 is a -1 over -4, which double negative makes a positive 1 over 4. That might have confused some of you, and I understand. So I'll go over it again. -4 over 1, we can flip it 1, 4, and since this one is a negative, why not make this one a positive? That's the other way of doing it. We see that when one slope was positive, the perpendicular slope would be negative. So likewise, when we have a negative slope, why not make its perpendicular positive? Now let's graph this new 1/4 slope. We're going to go up 1 and right 4. 1, 2, 3, 4. And when we graph it, it goes here. We're going to go down 1 and left 4 because we had this double negative. So down 1 and left 4. And here, when we draw this, you can see that we have a 90-degree angle in our slope. That means that this is perpendicular. Let's say you made a mistake. You had said -4 over 1 becomes 1/4, and since this is negative, we're going to keep this negative. This is what would happen in your graphing. You're going to go down 1, and you're going to go right 4. And you're going to see that, yes, these are intersecting, but do they intersect at a 90-degree angle? Let's test it out with this sheet of paper. No, this corner is not fitting into the acute angle, and this corner is not fitting into this very obtuse angle. So since this is acute and this is obtuse, they're neither perpendicular nor parallel. They're intersecting. All right, on to our next example. We have a -3/2 slope. To do a parallel line, you'd go down 3, right 2. Down 3, right 2. Parallel line also has a -3/2. Down 3, right 2. To do perpendicular, you're going to take the -3/2. You're going to flip it. So you have a 2 on top now and a 3 on the bottom. This one was negative. We're going to have to write it positive. You could also think, since it was -3/2, you are going to need to put a negative on there. You end up with a negative in the denominator, and you get 2 negatives. That'll make a positive again. So we have this positive 2/3, up 2, right 3. You could also go down 2, left 3. I was just talking about a double negative. As you can see, we have a 90-degree angle here. So the new slope is 2/3. What if you had messed that up? You had said -3/2. Well, I know I need to make it negative, and a negative of -3/2 is positive 3/2. A lot of people do this when they forget to flip. They understood the sign, but they forgot to make it 2/3, flipping the denominator and the numerator, making the reciprocal. Let's look at this positive 3/2 slope. So I graph it up 3, right 2. I graph it down 3, left 2. Look, again, it's intersecting. And it also has a cool property that it is symmetrical across the axis, but it is not perpendicular. And this is the proof. When I stick this corner into the paper, I I get an acute angle, my corner gobbles up this. And when I stick it here, there's an obtuse angle. There's definitely extra space between the corner. So this is not a 90-degree angle. Not a 90-degree angle. That's one of the biggest tests, is they'll throw you this 3/2, and that is neither perpendicular nor parallel to this -3/2 slope. Finally, we have a zero slope. A zero slope is a flat line. We've talked about how it's so flat, it has so little slope, zero slope, that a marble wouldn't roll on it, or that it would be easy for someone to walk on. The opposite, a parallel line for a zero slope would also have a zero slope. It would also be flat. It'd be like stairs on a staircase. Perpendicular slope is the opposite, and I'm sure by now you know if you have a 90-degree angle, it's going to be an up and down vertical line. Now, what kind of slope does a vertical line have? Well, we've talked about the vertical line test and how a vertical line has an undefined slope. So the opposite of a zero slope is an undefined slope. An undefined slope is found on a line that's vertical, and a vertical line would have a, this is actually incorrect. This is y equals 0. Y equals 0. It would be a flat line. This is x equals 0. You could see this by going like, if x is 1, x is 2, x is 3. Now I graph this line, and this is my x equals 3 line. Or if I go back 1, 2, now I have my x is -2 line. So undefined slopes have x equals, remember they're not functions because they don't have y's, and horizontal lines with a zero slope, horizontal, zero slope, they have y equals graphs. That's perpendicular slopes. With these difficult problems, you can accomplish anything in this task.